In our next example, we'll take a little walk down memory lane. This is a famous problem which was posed by Samuel Pepys to Isaac Newton in 1693. Pepys asked Newton if it was more probable to obtain at least one ace, an ace is a 6, in 6 throws of a die, or to obtain at least 2 aces in 12 throws of a die. Newton quickly gave Pepys the answer, and Pepys disbelieved him. Let us make up our own minds on the score. Pause the lecture while you think about it. See if you can set up the calculation, and if you get that far, see if you can find a numerical estimate and answer Pepys. Start the lecture when you're ready. Now that you're back, each throw of a die, from the point of view of getting an ace, corresponds to the toss of a metaphorical coin whose success probability is 1 in 6. And therefore, as far as getting aces is concerned, each of a succession of throws represents a Bernoulli trial with success probability 1 in 6. And therefore, in n trials, the number of 6s obtained in this interpretation is S sub n, and of course it's going to be governed by a binomial distribution corresponding to n trials and whose success probability is 1 in 6. With this in hand, it becomes transparent and easy to write down a formulation, and all that will be left, all bar the shouting, is a numerical evaluation. So let's start promptly. The probability that in 6 throws of a die you get at least one ace, well, by additivity, it'll be easy to write it in terms of the complement that you get no aces, is 1 minus the probability that you get no aces in 6 throws. The probability of getting no aces in 6 throws is our old friend, the binomial probability, b of 0, with parameters n equal to 6 and p equal to 1/6. We simply write down the binomial probability, evaluate it, and we find it's about 67% approximately. It's quite likely. It's about the chance of getting at least 1/6 in 6 throws of a die is about 2 in 3. What about the probability of getting at least 2 6s in 12 throws of a die? Now, n, the number of trials, is 12, and p still remains 1/6. So the probability of getting at least 2 successes, again by additivity, the complement of that event is the event that you get either no successes or precisely 1 success. And therefore the probability of getting at least 2 successes is 1 minus the probability of getting no successes minus the probability of getting 1 success. Of course, these are our binomial probabilities. We just write them down, evaluate them, and we get simple binomial expressions which simplify very quickly, and a very simple calculator will give this for you. And we evaluate it, and we find the order about 62%. In fact, as Newton found and proclaimed to Pepys, it is somewhat more likely that you get at least 1 ace in 6 throws than that you get at least 2 aces in 12 throws.